Okay, in this video, we're going to work through some problems that are similar to your review, because that's usually what people ask for in the live review sessions. So I made it some problems that are pretty similar, kind of give you the idea of what you need to do, and then you can try the review sheet on your own, and then you also have the review sheet solutions as well, but try the review sheet on your own before you look at those solutions. Okay, so the first problem is like number one on the review. It says write in terms of sine and cosine or cosine and simplify. So we've got secant beta, cotangent beta. So let's go ahead and write that. Okay, so secant beta, cotangent beta. And we're going to write these in terms of sine and cosine. That's the hint that's given to us, but that's really what makes sense here. So secant is 1 over cosine. And cotangent is cosine over sine. So when we write them as sine and cosine, a lot of times we can see what's going to happen. So we see the cosines will cancel. We get 1 over sine beta. Okay, it doesn't really tell us what form of answer we're going to have here, so you would look for that. If it was multiple choice, you'd look for that. It might be 1 over sine beta, or it might be written as cosecant beta. Okay, so 1 over sine would be the same as cosecant. So probably cosecant would be considered the most reduced unless the directions said your answers will be in terms of sine or cosine. So I would say these last two, either one of those would be good. And remember on the test it's going to be a multiple choice situation. So you just kind of see what you need to do to match. Okay, going on to the next one. This is like number 8 through 10 on the review sheet. So we've got secant theta, sine 2 theta. Okay, so we want to simplify this. Again, probably writing as sine and cosine. I've got a secant here. Can't do too much with secant and sine, but I can write this as cosine. Sine 2 theta is a double angle identity, so let's go ahead and substitute all these. So secant would be 1 over cosine. Sine 2 theta should be on your formula sheet as 2 sine theta cosine theta. So now we can see that the cosines will cancel. We've got a cosine on the bottom, a cosine on the top, and we get 2 sine theta. And there's really nothing else you can do with that, so that should be your answer. Okay, so this is a matching one, like number 11 through 17 on your review sheet. So let's see how these work. So you've got quite a few matching ones on the review sheet and on the test. So we've got cosine and sine values over here. It might not be too obvious what you're going to do with them, so you might also want to look to the right to see what we have. So it looks to me like maybe what's on the right would be a little bit easier to deal with. I think I see a typo here. Let's see what happens. Okay, so let's see. Not obvious what to do with cosine 115, so let's go to the next one. 1 minus, okay, so B is 1 minus cosine 70 over 2. So if you look at your formula sheet, that should jump out to you as a half angle identity. So the 1 minus, they both look very similar. The 1 minus cosine is the sine half angle identity. Okay, so let me just write it down here real quick. So when you see sine of x over 2, it's going to be equal to 1 minus cosine x over 2, square root, and then of course plus or minus. So you look at, this is what you're looking for in your review sheet right here. So you see that 1 minus cosine x, and you say, yes, I'm in that form right here. So what I'm going to get is I'm going to get sine half of that angle. Okay, so this is the sine half angle identity. So I'm going to get half of that. So let's erase that. And I'm going to get sine, and I'm going to get half of 70, because that's what the formula looks like. So that's going to be sine of 35. So that's going to be this one right here. So this is B. C also looks like a formula. So I've got cosine, cosine minus sine, sine. So you should recognize that as the cosine sum identity. So cosine A plus B is going to be cosine A, cosine B minus sine A, sine B. So cosine means the functions match, but the sign is opposite. All right, so you look on your review sheet and you see that, find the one that matches this format. So this is going to be cosine sum. Cosine sum. All right, so C is going to be cosine 150, cosine 60, minus sine 150, sine 60. Okay, so this is going to be cosine sum, 150 plus 60. So that's going to be cosine of 210. And that is number 3. Okay, so the last one should match. So between sine and cosine, you should know the relationship there, or you can look at your review sheet. So if I want to get from cosine to sine or sine to cosine, we're kind of working on the right here, so probably want to go from cosine to sine. The relationship that we have between cosine and sine is that cosine of A is equal to sine 90 minus A. Okay, or there might be another one on there that maybe you want to try, but this is going to be the one that works. I don't think there's any others that are specifically just cosine and sine. We've got a lot with cosine squared and sine squared. All right, so if we've got cosine 115, that's going to be sine 90 minus 115, and that's going to give us the sine negative 25. Okay, so that's this one. I thought we might have had a typo there, but that actually worked out. Okay, so we get sine of negative 25 and those match. So on the review sheet, you've got more matching ones, but it's going to work the same way. You're going to look for things that match your formula sheet. That's what you're looking for here, formatting things that match. And sometimes it might not be obvious, like we didn't really know what to do with cosine 115, so we went on to the other ones, and that's okay too. Okay, next one. All right, so this one is like number 18. You've got a bunch of matching ones on the review sheet, so I didn't do like a ton of them here, just to get you kind of the idea to get you started. So this one is like number 18. We're going to use sum or difference formula to find the exact value of sine 7 pi over 12. All right, so we need a sum or difference that gives us 7 pi over 12 that we can find the exact value of. So I'm going to erase this, but I'm just going to kind of walk through the mindset here. So 7 pi over 12, I need to break this up as a sum or difference. I'm going to go ahead and do a sum, but you might be able to figure out a difference that would be that would work. It would look a little bit different along the way, but you'll get the same answer. So 7 pi over 12. So you might think, well, I could do like 6 pi over 12 and pi over 12. The 6 pi over 12 is going to reduce to pi over 2, and that's good because that's on your unit circle. But the pi over 12 is not. So that one's not going to work. We could also do 5 pi over 12 and 2 pi over 12. The 2 pi over 12 works, but 5 pi over 12 again does not. So we could try 4 and 3. Let's hope this works because we're going to be out of options here. So 4 and 3, yes, this works because these both reduce to things that I know. This reduces to pi over 3. This reduces to pi over 4. I have both of those on the unit circle, so that's what I want to use. Okay, so when you see these where it says use sum or difference or half angle, you can probably do this in your head, I hope, but you just go through combinations until you get to a combination where both of them are on your unit circle. All right, so we're going to have sine of 7 pi over 12, and I'm going to break this up as 4 and 3. And if I reduce that, that's the same as pi over 3 and pi over 4. Okay, so that's what we're looking for. Those two numbers are on the unit circle. The other ones wouldn't work. These two will. And then we look at our formula sheet to see the sign formulas. So sine, you're going to get opposite functions, same sign in the middle. So I'm going to get sine pi over 3, cosine pi over 4, minus, no, sorry, same sign in the middle, plus cosine pi over 3, sine pi over 4. Okay, so sine gives you opposite functions, same sign. And then you should be able to look at your unit circle for this. So at pi over 3, sine is square root of 3 over 2. Cosine is square root of 2 over 2 at pi over 4. Cosine at pi over 3 is 1/2. And sine at pi over 4 is square root of 2 over 2. So putting this together, we're going to get square root of 6 over 4. And we're going to get square root of 2 over 4. And we can put that together, common denominator, as square root of 6 plus square root of 2 over 4. And I cannot put square root of 6 and square root of 2 together because they're not like terms. So remember, for radicals, they have to be exactly the same to put them together. Okay, so you could try, maybe you try on your own if you want. You could try like 9 pi over 12 minus 2 pi over 12. That would be another combination that would give you 7 pi over 12. You should be able to reduce these and get them on your unit circle. So maybe you could try that and work through the same, break it up as a difference, and you should get the same answer in the end. Okay, so lots of different ways to work these problems. If you think, oh, I did it a different way, it might be okay. All right, so this one is like numbers 23 to 25. We're looking for arc sine or sine inverse of negative square root of 2 over 2. So numbers 23 to 25, these should be values that are on your unit circle. The key here is that you've got to remember what quadrants your inverse functions are going to return. So remember let me put them up here, put them here. Inverse sine is going to give you negative pi over 2 to pi over 2. Inverse cosine is going to give you 0 to pi. And inverse tangent is going to give you negative pi over 2 to pi over 2, but not included because of the asymptotes. Okay, so sine and tangent are going to be fourth quadrant, first quadrant. Cosine is going to be first quadrant, second quadrant. So we're looking for sine, arc sine or sine inverse, negative square root of 2 over 2. So you're going to look on the unit circle. Okay, you're going to look on the unit circle for where you have negative square root of 2 over 2. So that's going to happen in the third and fourth quadrant. Okay, so you should see that at the third and fourth quadrant. The third quadrant is going to be, it's at pi over 4. So you're going to get 5 pi over 4, and then you're going to get 7 pi over 4. Okay, so that's what you should be seeing on your unit circle is 5 pi over 4 and 7 pi over 4. But look at sine inverse. It's got to be negative fourth quadrant, positive first quadrant. So we have 7 pi over 4, but we don't want that. That's the positive angle. We want the negative angle. So if you're not sure, you can take 7 pi over 4 over here. You're like, okay, that's quadrant 4, but I need the coterminal angle. I need the negative version. And you could subtract 2 pi from that. And that's going to give you negative pi over 4. Okay, so if you can't do that in your head, that's okay. Just remember that you're going to do plus or minus 2 pi to get your coterminal angles. So that one should give you negative pi over 4. Okay, so these values that are in the unit circle, you can use the unit circle, but you also have to remember the domain and range for sine, cosine, tangent, and the inverses.